Hello everyone, welcome to my channel Class 9 Math Simplified. So today, as the thumbnail suggests, we'll be discussing the difference between rational numbers and irrational numbers. So I'll tell you one thing, most of the class 9 students lose marks in maths not because the chapter is difficult, it is just because of small confusions. So in this video, we'll clearly understand rational numbers and irrational numbers in the simplest way possible. And I'll also tell you the common mistakes that cause marks to be cut in the examinations. So let's start. So first we'll be understanding what are rational numbers. Okay, first part is what are rational numbers. So as the definition suggests, a rational number is a number that can be written in P by Q format. P by Q format, and here P by Q suggests us that can be written in fraction format. A number that can be written in fraction format is a rational number. Okay, where where P and Q are integers. P and Q should be integers and Q should not be equal to 0. This condition is generally coming because if Q will be equal to 0, the fraction 1 something divided by 0 will tend to infinity, and infinity is not a rational number. That is why Q should not be equal to 0. So it is saying a rational number is a number that can be written in P by Q form, basically a fraction format, where P and Q are integers and Q should not be equal to 0. So now let's check some examples of rational numbers, like an example of 1 by 2. If we take an example of 1 by 2, 1 divided by 2. Here 1 is basically P, 2 is basically Q, and we can see that this is a P by Q format number. And if we now check the conditions, P and Q should be integers. So 1 is an integer, 2 is an integer 2. Therefore, and Q is not equal to 0 as 2 is not equal to 0. Therefore, we can say that 1 by 2 is a rational number. As simple as that. 1 by 2 is a what? It's a rational number. Similarly, if we check for another number 3 by 5. 3 by 5, we can say that here 3 is directly corresponds to P, Q corresponds to Q, 5 corresponds to Q, and 5 is never equal to 0. So therefore Q is not equal to 0, and we can say that 3 by 5 is also a rational number. So are you getting how to check a number is a rational or an irrational number? So if we now take an example of an integer 4, now let's see if integers are rational numbers or not. Okay, if we take an example of 4, 4 can be written as 4 divided by 1. 4 divided by 1 is a P by Q format number. You can see it clearly. Is a P by Q format number, and 1 is not equal to 0 and Q is not equal to 0. Therefore, we can say that integers are also rational numbers. Integers are also rational number. 0, similarly for 0, we can say that 0 can be written as 0 divided by 1. Here 0 and 1 corresponds to P and Q, and 1 is not equal to 0. Therefore, 0 is also a rational number. Got it? So some checkpoints, P and Q are integers. We have seen that. Q cannot be 0, done. Can be written as a fraction, done. We have understood these three conditions for a number to be a rational number. Okay, conditions we have understood. Now let's move forward. Yeah, a very important property of rational numbers is the decimal property, which basically tells us whether a decimal value is a rational number or an irrational number. So it is saying that if a decimal expansion of a number is a terminating decimal, Terminating decimal generally means if the decimal value is ending somewhere, ending. Terminating is basically ending. If a decimal value is ending somewhere, therefore we can say that that number, that terminating decimal number is a rational number. Similarly, if a decimal expansion value is a repeating decimal generally means, if we take an example of point 44444 dot, if we can see that this number, if we take an example of 0.4444, here you can say that the number 4 is getting repeated multiple times, so therefore we can say that this number is a repeating decimal. And we have seen that if a number is a repeating decimal, therefore it should be equal to a rational number. So these decimal properties are very important, as students generally make mistakes while solving these type of questions. They forgot about the property. Got it? First, the number should be a terminating decimal, and second, the number should be a repeating decimal. Got it? For terminating decimal, I can give you an example of 0.24, as simple as that, 0.24. As it is having an end after 4, there is no value of decimal, therefore we can say that 0.24 is a rational number, as 0.24 can be expressed as 24 divided by 100, and 24 divided by 100 is a p by q format number, and 100 is never equal to 0, as it is satisfying all the conditions of a rational number. Therefore we can say that terminating decimal are also rational numbers. Got it? Now let's move forward, and now let's discuss what is an irrational number. What is an irrational number? So an irrational number is a number that cannot be written in form of p by q, and whose decimal expansion is non-terminating and non-repeating. So if I ask you from a general question like what is an irrational number, your first thought will be going that irrational numbers are opposite of rational numbers, and that is the correct thing. Basically, irrational numbers are the opposite of rational numbers. You have seen that rational numbers were being able to written in form of p by q, that is fraction format, but irrational numbers cannot be written in form of p by q. Highlight this point. Irrational numbers cannot be written in form of p by q, basically fraction format. And you have seen that the decimal expansion of rational numbers were terminating, like 0.24, but here, as irrational numbers are opposite of rational numbers, the decimal expansion of them will be non-terminating. Got it? Non-terminating as in 0.4789 dot, like a very large value which is not ending at a single point. Similarly, for, and it is saying that the decimal expansion should be non-repeating too. As we have seen in rational numbers, the decimal expansion for them was repeating, like 0.44444, but here the in irrational part, the decimal expansion should not be that should not be repeating itself. Got it? The decimal expansion should not be equal to 0.4444, it should not be equal to this sort of number. सो समझ गए, रैशनल नंबर वो होते हैं जो फ्रैक्शन के फॉर्मेट में नहीं लिखे जा सकते हैं और जिनका डेसिमल एक्सपेंशन नॉन टर्मिनेटिंग हो और नॉन रिपीटिंग हो. वेयरएज जो रैशनल नंबर्स थे, रैशनल नंबर्स वर द नंबर्स विच कैन बी रिटन इन पी बाई क्यू फॉर्मेट, बट जिनका जो पी बाई क्यू फॉर्मेट और इनका डेसिमल एक्सपेंशन टर्मिनेटिंग होना चाहिए और रिपीटिंग होना चाहिए. गॉट इट? I hope you are getting concepts cleared now. Now the key points for an irrational number is it cannot be written as p by q. Got it? We have seen it. Decimal never ends directly corresponds to non-terminating part, whereas decimal does not repeat corresponds to the non-repeating part of decimal value. Got it? Now if we move forward and see some examples of an irrational number, like an example of root 2. If someone asks you, is root 2 a rational number or an irrational number, you will directly say that root 2 is an irrational number. And why is it so? Because I'll tell you, root 2's value is generally 1.41421. After that, many decimal numbers generally come after that. Okay, so the decimal expansion of root 2 is very big. It is not ending basically, it is very big, not ending. And if we have seen that if a decimal expansion is not ending, not ending generally corresponds to what? Non-terminating. If a decimal expansion is not ending, that corresponds to non-terminating, and non-terminating decimal expansions are generally what we have studied it, they are generally irrational numbers. Similarly, if we take an example of root 3, same example, root 3 is not a perfect square root. Root 3 value is also 1.7. We can write it as 1.7 something. After that, many decimal numbers are there. We can write it as 1.7 something. And as we have seen that this number is not ending, so it is basically non-terminating, and non-terminating numbers are generally what? Irrational numbers. Got it? Got these two examples. Now if we take an example of pi, you have studied, you will be thinking like pi value is to 3.14, it is ending, but then why is it that it is an irrational number? But I'll tell you, 3.14 is the approximated value of pi. The value of pi is very big. It is the decimal value. There are many numbers after 4, but we have approximated this value as 3.14 to make calculations easier for us. Got it? So this number is also non-terminating, and as this number is non-terminating, it is an irrational number. I hope you are clear with the examples of irrational numbers. The decimal property of irrational numbers that suggests us if a decimal expansion is non-terminating and non-repeating, then the decimal expansion or the number should be an irrational number. Got it? I hope these decimal properties, the definitions of both rational and irrational numbers are clear to you now. Now if we move forward to see some important examination confusions, like these are very important part. Like if like the student generally makes mistake in these sort of questions, if they see a square root above any number, they'll think that there is a square root, यहाँ पे एक square root दिख रहा है मेरे को, I should answer this as an irrational number. But that is not generally we think like. We'll be thinking it like that. Root 4 is a perfect square root of 2. 2 is an integer. 2 is an integer. And integers we have studied earlier. Integers are basically what? Rational numbers. Got it? These sort of mistakes you should be now not making. Okay, like similarly, if we take an example of 0.333, people or students see that 0.3333, they just take the first property, that is the number is non-terminating, but they never see the second property, that the number is also repeating itself. 3 is repeating itself multiple times, and I have told you in the decimal property of rational numbers that if a number is getting repeated multiple times, it is not an irrational number, it is basically a rational number. Got it? If a number is getting repeated multiple times, it is not an irrational number, it is a rational number. If the number would have been 0.3356789 dot, as now you can see the number is not ending and the values are also not repeating, therefore now the number will be an irrational number. Got it? I hope now the confusions are very well clear to you now. Sorry, irrational number. Now I'll tell you one thing. This is a two-step examination rule which you should remember in while solving the questions, in which they generally ask, tell me whether the given number is a rational number or an irrational number. So here एक टू स्टेप एग्जामिनेशन रूल टेक्निक है. बेसिकली तुमको उस क्वेश्चन से दो क्वेश्चन पूछने हैं. यू शुड आस्क द क्वेश्चन टू क्वेश्चंस दैट क्या तुम पी बाई क्यू के फॉर्मेट में लिखे जा सकते हो. कैन इट बी रिटन एज पी बाई क्यू फॉर्मेट. इफ़ येस, अगर वो आंसर दे हाँ मैं लिखा जा सकता हूँ, इफ़ यू कैन सी दैट इट कैन बी रिटन इन पी बाई क्यू फॉर्मेट, इफ़ येस देन यू विल बी आंसरिंग दैट यहाँ तुम तो फिर रैशनल नंबर हो. तुम क्या हो? रैशनल नंबर. अगर वो बोले नहीं मैं पी बाई क्यू के फॉर्मेट में नहीं लिखा जा सकता हूँ, तो तुम यू विल बी आंसरिंग लाइक मैं इर्रेशनल नंबर हूँ. तुम तो इर्रेशनल नंबर हो क्योंकि तुम पी बाई क्यू के फॉर्मेट में नहीं लिखे जा सकते हो. The second question that you will be asking from the question is the decimal terminating or repeating. क्या जो तुम्हारा decimal expansion है वो terminate हो रहा है और repeat हो रहा है. अगर इसका आंसर आए yes, हाँ मेरा decimal expansion terminate हो रहा है और repeat भी हो रहा है, तो you will be answering that फिर तो तुम पक्का rational number हो. rational number. इफ़ इट सेज नहीं मेरा नहीं रिपीट हो रहा है, मेरा टर्मिनेट भी नहीं हो रहा है, नॉन टर्मिनेटिंग एंड नॉन रिपीटिंग, सो तुम यू विल बी आंसरिंग दैट फिर तो यू आर एन इररेशनल नंबर. एज सिंपल एज दैट. This is a two-step examination rule technique which you will be using. Then you will be having a then it will basically very easy to solve the questions. So yeah, if the main crux, if yes then rational. Basically if the answers for both the question is yes, then the number is rational. If the answer for both the question is no, then irrational. Got it? If yes then rational, if no then irrational. So I'll just do a quick recap. A number in p by q format, I have told you multiple times, rational. A number with terminating and repeating decimal, multiple times I have told you, rational. A number with non-terminating and non-repeating decimal expansion, therefore irrational. So yeah, that's it for today's video. I hope now you have understood the concept of rational numbers and irrational numbers, and you'll be able to solve the questions very easily. Thank you. Please like, share and subscribe to my channel, Class 9 Math Simplified. Thank you.